So section 4 talks about rational exponents. Okay, and what that means is that, say you're given some radical expression, okay, you can rewrite it as a rational exponent, like that, okay, where n is the index n is the index of, notice how n is the index of the radical expression, and then the 1 is the power of the radicand. Okay, everyone see that too? So like here we have x to the power of 1, but we don't have to write it. So the 1 will be the numerator, and the index will be the denominator. Okay, so here's an example. I want you to rewrite the cube root of 216 as a rational exponent. Okay. All right, so did everyone get 2/16 raised to the 1/3 power? Did anybody not get that? Okay. All right. So yes, even though our first instinct is simplified, but for right now, I just wanted you to get the chance to rewrite it. And with this rule, this little rule, it's actually interchangeable. It goes backwards. So if I had, for example, let's say the 5th root of 4, I can rewrite it as 4 raised to the 1/5.
Is it always going to be 1?
Good question. No, the numerator is not always going to be 1. There are cases where the numerator is a different number. And that will go in the rule for this. Say you have here's a radical expression where n is some number other than 1. To change it into a rational exponent, it would be x raised to the m over n. Okay? And another way to rewrite n root of x to the m is saying n root x to the first, and that whole thing is being raised to the n power. And then this expression also means x m over n. See your little kind of like triangle-ish. So this you can rewrite as this. Both expressions mean x raised to the m over n. So I have an example for you. So I want you to rewrite rewrite 7th root of x cubed as a rational exponent. Okay. So did everyone get this? Yes. Did anybody not get that? Okay. So so now we can start, now that we have like an idea of how to rewrite radical expressions to rational exponents, let's start simplifying some examples. So one example I'm going to use is, I'm going to rewrite, so one example there you go. Yes, Julie. So from previous sections, we know that because they have the same index, we can combine the radicals on the inside. So we'll get the fourth root of 625, which is just 5. However, the technique for this in rational exponents is that, yes, you could change this to 5 over the 1/4. Hold on, let me get rid of that. Okay, 5 over 5 times 125 to the 1/4. But notice, yes, here I don't have the same base. But what could I do to the 125 where I have a common base? I could change 125 to, I said, so here we don't have the same base, right? So, but I can change 125 to have, the base would be 5. So I can change 125 to have a common base of 5. And what? So how can I change 125?
5 and 5.
Junie? No, not the exponents. I just want to change
5 and 25, right?
5 and 25, and 25 can change to what? 2 5. So how many 5s total do I have? No. So 3 from 125. That's what I was trying to get at. Is 3 from 125. So 125 can be changed to 5/3, and that whole thing is being raised to 1/4, and you can multiply it by that. So now I can rewrite my expression as 5 to the 1/4 times 5 to the 3/4, right? Because having an exponent here being raised to another exponent, you multiply the two exponents. Okay, now that I have the same base and they're being multiplied, what can I do to the exponents? Right, I can now add the exponents. And I'll have, so 1/4 plus 3/4. Okay, will give me 4/4. So this whole thing means that 5 is being raised to the 4/4. And what's 4/4? So we'll get 5 to the first. And notice how we got 5 to the first over here as well, using our other property. Here we could,
It's just another way of doing it.
right, using rational exponents is another way of doing this kind of problem. Okay? This will give, so I have an example here. So here I have the square root of 7 times cube root of 7. So our first step, since we don't have indexes that are the same, we write them as rational exponents. So the square root of 7 becomes 7 raised to the 1/2. And then the cube root of 7 is 7 raised to the 1/3. Since I have the bases are the same, what can I do to the exponents? I can add them. So I will see as 1/2 plus 1/3. Now with fractions, when dealing with adding of fractions, what does there need to be?
Common denominator.
A common denominator. So a common denominator would be 6. So this would be 3/6 plus 2/6. And now I'll have 5/6. So therefore, my answer will be 7 raised to the 5/6 power. And you can actually, if you wanted to, you can try to simplify it. But in this case, since my denominator is 6, which means my index of my radical will be 6, and my power of 7 is 7 to the 5th, will I have enough to simplify this kind of radical expression if I wanted to? Probably not. Probably not. So I would just leave it like this. Okay? All right. Now, what would happen if I had a number and I had it raised to like a negative 2.5 or something like that, a decimal? Okay? What if I had something like this? I have to do what? I have to change that I have to change the 2.5 into a fraction. So I would then have to so then I'll have negative 7. Let's see, 2.5 as a mixed number is 2, is something like that. So as a fraction, I take my 2, I multiply it with my denominator, and then I add the numerator, and I will get a regular fraction. So this will be 5/2. Okay. All right. Now, since my denominator is 2, okay. Now, before we do that, what rule does it state when we're dealing with negative exponents? There's a rule. I have to flip it in a sense. So I would have 1/7, and I'll change my exponent now to positive. And actually, let me just change this real quick because my 5 didn't come out that well. So 7, 5/2. Okay? So whenever you have your negative exponent, in a sense, you'll have to flip it. So it'll be 1/, this expression, but then your exponent turns to positive instead of negative. Okay? But I can simplify 7 raised to the 5 halves even more. What's a way I could do that that we've seen before? Well, something similar to that, but I can also do this. I could rewrite it so that way I'm taking the square root of 7 to the 5th, right? Because our rules in this section are interchangeable, so which meaning that you can go reading left to right and right to left. Okay? So now that I have square root of 7 to the 5th, I can simplify that because I have more 7s than the index. So what would be a way I could simplify 7 to the 5th?
7 squared to the raised to the third power.
7 squared raised to
7 cubed raised to the second power.
Well, if we had 7 raised to the second power, that would actually be 7 to the 6th. Okay. Well, what does 7 to the 5th mean? It means we have 5 7s, right? 5.
So that equals 35.
So 1, 2, 3, 4, 5. So that means, but how many do I need so that way I can bring it out of the radical? I need 2. So I'll take this group of 2, and I'll take this group of 2. Okay, this means I'll have 7 to the first power times 7 to the first power.
Equals 7 to the second.
Okay, right? And I'm just going to bring down my screen a little bit. So this will be 7 squared times the square root of 7, because we have 1 7 left inside the radical. Everyone see that? We have 1 7 left inside the radical, so that's this. And now I'll have 49 square root of 7. That will go right here. So I'll write it. 49 square root of 7.
You can't have a square root at the bottom.
Right, but I can't have a square root in a denominator, so I have to multiply top and bottom by only square root of 7. You don't have to multiply by the 49. Okay, so my answer will now be square root of 7 over 49 times 7. And it will be the square root of 7 divided by 343. And then you're done. And that's a 3. Okay. All right. One more example. This will appear on your homework tonight. Yeah. So one way we can actually do this also is take the 2/3 and distribute it to each term. Okay, so we see we have x, we have -8 is raised to what power? It's raised to the first power. So 1 times 2/3 will be 2/3. X is also being raised to the 1 power, so we can have like x raised to 2/3. All right. First thing, and then so we'll have square root of xy, that whole thing raised to 2/3. So Tina, kind of close to what you said. Okay. So now one thing we gotta point out is we gotta change the square root of x and y to a rational exponent to make it easier to solve for. So I'm just gonna rewrite the line. And then as like that. right? Then I'm going to simplify the 1/2 and a 2/3 through multiplication. And I'll do that on the side right here. So if you follow the arrow, I'll have yx raised to the 2/6. That's 1/2 times 2/3. And then to reduce two sixes, it'll become what kind of exponent? X to the 1/3.
That would be just x.
Oh, I apologize. Thank you. Sorry. Yes. Well, no, the blue here is a 3. And then this is supposed to be a 2. There. And then this is supposed to be a 3. Okay? All right, so now let's see what I do. So what's a way I could simplify without putting these in radicals? What's another way I can simplify? Well, I can change -8 to what kind of number? What do you think? Not quite. We're dealing with powers here. So it's almost like, so this is saying the cube root of a.
Is it the cube root of 64?
So we're saying like the cube root of 64 here, right? Okay. But I can automatically change the -8 to a number raised to a certain power instead of doing the cube root of 64. Nope. Well, okay, that's the ending amount. But can I also change, I can change -8 to -2 raised to the 3rd power and have that being raised to the 2/3 power. Because in this instance, what happens to the 3's?
They cancel each other.
In this instance, the 3's do cancel each other out, leaving, well, actually, yeah, it would be +4 because so with the variables here and here, let's put them underneath let's put them in radicals. So this would be cube root of x², and then this would be cube root of x times y. All right. Since I have like indexes here and here, I can combine the variables that are inside. So I'll get the cube root of x cubed and y. Now notice I have x cubed and I'm taking the cube root of it. Therefore, I can have what on the outside? I can have x. All right, and I'll just see. And I have what kind of power of y here? I just have 1, so I'll just leave it as the cube root of y. And this will be your answer.
Should the final answer have radical or should it be?
Here. We didn't do this right now, but please also, when you're at homework tonight, look at problem 4 in your book. Okay, this is dealing with division now. Okay, and follow the example that they give you for problem 4. Okay, and then I did take out number 43, which was a division problem. But I want you to actually try 43 now. Not right now, but for homework tonight. Do problem number 43, and I'll add that back in. Okay? So this video will be posted on my porters, so you guys can refer back. And you do try the homework that is tonight, which is rewriting expressions as, is what we did in here. Okay?